Hi, my name is Guerra. Welcome to my passive solar home on Easley Road. Let's go inside and look at the features. All right, so here we are in our garage. As you can see, we're definitely still under construction. I'm holding a section of a SIP, S-I-P, a structural insulated panel. All the exterior walls are made out of these SIPs in this house for insulation, for a high R value. In the garage here, all of our exterior walls are made out of a 4-inch. What I'm holding here is a 6-inch structural insulated panel, and all the roofing is made out of a 10-inch structural insulated panel for even more insulation. All right, here we are in the sunroom. We're facing directly south here. I'm standing on 5 inches of concrete, which provides a thermal mass that'll heat up as the sun shines in here in the winter time. And actually, you'll notice we are starting to get a little bit of sun. We're in the middle of August here. The properly designed overhangs allow the sun to enter the sunroom during the winter time when the sun is low, but when the sun is high in the summer, we're basically shading out all of that heat gain during our hot summer, our August, our July, June, and those months. But now as we start to transition into fall and August and September, we're getting about maybe an inch of sunlight that's shining on this floor, and that'll start to increase where in December, on the shortest day of the year, we're going to be getting full penetration of the sun into our sunroom. And then over here to my right, we have a rock wall, which will also get some sun only in the winter time, and it provides some additional thermal mass. And also, in addition to the thermal mass, we have about 600 feet of PEX tubing, radiant in-floor heating that we're going to use to heat the sunroom, and also to transfer the heat that we gain in this concrete throughout the rest of the house. And also, you'll notice the dark stained concrete here, which will absorb more heat from the sun in those winter months when we need that heat. So here we are about 2 feet above that sunroom that we were in last time. One of the reasons that sunroom is dropped is so that in the winter time, when the cool air settles, it'll drop into the sunroom into kind of a non-living area, and so we retain that heat in here. I'm also standing on a concrete floor here that's sitting on top of a wooden subfloor. I poured 2 inches of concrete on this and also laid in about 1,200 feet of PEX tubing for additional radiant in-floor heating. So we have more thermal mass. The 2 inches of concrete here on this floor, about 1,200 square feet, is about 24,000 pounds of thermal mass. We also have a vaulted ceiling in this area here, some additional south-facing windows, so this will kind of act as a sunroom as well. Again, the properly designed overhang, so we're not getting any sun in here in those summer months and get full sun in those winter months. And then we have another thermal mass rock wall here that will get sun in the winter time when we start getting when that sun drops in the sky, and we start getting some solar heat gain on this thermal mass. It heats up during the day, and then after the sun sets, it's going to radiate that heat over the course of the night, as well as the thermal mass on the floor. One of the things, this house has so much thermal mass that it's going to take a really long time for it to change temperature. As it heats up, if you maintain about a 70-degree temperature in this house, it would take probably almost a week for it to change by 5 degrees, even with no external or internal influences, internal heat that we're putting into it from a boiler or from the sun. So the thermal mass really maintains the temperature inside this house. Okay, welcome to the utility room. Here I'm standing in front of our heat recovery ventilator. It's a HRV. When you do a SIP house, the house ends up being very tight, where we don't have any air leaks, as opposed to a traditional stick frame house where you're going to end up with some air leaks and some infiltration. In a SIP house, everything goes together. It's basically a composite way of construction where everything goes together so tight that you don't have any infiltration coming from the outside air. So in order to get fresh air into the house, we're using a heat recovery ventilator. And so what that does is it sucks air from the outside, but instead of just using the plain air from the outside, if it's 90 degrees outside and you want to keep your house cool, it's going to use the heat exchanger to drop that 90 degree air temperature down from using the air that's inside the house. So if it's 70 degrees inside your house, it's 90 degrees outside the house. When you bring in that 90 degree air, the heat exchanger is actually going to drop that 90 degree air down to about 80 degrees. It'll meet somewhere in the middle there. So 90 degrees outside, 70 degrees inside, it'll meet somewhere in the middle. When it's 0 degrees outside and it's 70 degrees inside your house, it's going to do the same thing, where it's not going to bring in just 0 degree air into your house. It's going to heat that air using the air inside the house up to a higher temperature. So you're not just bringing in the straight outside air, you're bringing in fresh air, but you're using the heat exchanger to either raise or lower the temperature of that air. And so we have 4 pipes that are hooked up to this thing. We've got one of them, this one right here, is actually what's providing the fresh air into the house after it goes over the heat exchanger, which is the square unit right here. There's also a filter, there's carbon filter options, so you can improve the quality of your air that you're bringing in from outside. So this is all the fresh air that goes into the house. This other pipe here, this other duct here, is all the stale air that's sucked out of the bathrooms. It runs continuously. You have some controls on here where you can change the controls. In the bathrooms, I put all the exhaust fans in the bathrooms. They replace your typical exhaust fans. They run all the time. You can set it to run at higher speeds or lower speeds. When you go into the bathroom and flip your fan on, it actually kicks up to a higher speed on your heat recovery ventilator. So you're sucking out more stale air and also pumping in more fresh air into the house. And then these other 2 over here, these are going all the way up to the roof, and that's what's coming in. So basically we have our fresh air coming in here on this side, and then the air from inside the house is used to then heat up that fresh air or cool down that fresh air depending on our season. Okay, and we also have in our utility room here, I talked about the PEX and the concrete floors. Here's all our PEX that hasn't been plumbed in yet, but this is all the PEX piping, 1/2-inch PEX piping that runs through all the floors, including the floor that we're standing on now. We're in the basement. We've got another 5 inches of concrete, so some additional thermal mass and some additional control of the temperatures throughout the house using this PEX piping just to pump water through. This will be hooked up to a boiler unit. The heat demand on this house is only about 50,000 BTUs for just the heating, and then you'll have some additional demand for your domestic hot water as well. Okay, so now we're back outside. Another feature of this home is that I used insulated concrete forms for all the foundation walls. This is about 2.5 inches of foam on each side, and this is for an 8-inch foundation wall. So what that gives me is that provides insulation and the forming for the foundation wall. So this acts as the forming for when you're pouring the concrete, and it also then remains in place after you pour the concrete. It remains in place and provides about an R40 wall on all of your foundation walls for some additional insulation. And also when you're looking at your overall efficiency, including your cost and your materials that you're using, the concrete forms, since they stay in place, give you some additional efficiency, some additional energy efficiency, and also through the construction efficiency as well.